Welcome to www.shipcalculation.com, Marine Offshore Engineering Consultant. Today's topic, Davit calculation. This spreadsheet calculation to aid in Davit design in accordance with American Institute Society Construction 6th edition, 9th edition, and 3rd edition LRFD. You might referring to the any other rules also related with the lifting, like the Noble Denton, any other class, GMP, ABS, NK, LR, or BKI. This debit arm calculation, this debit arm, many vessels using with this, they are install this debit arm into the main deck area. Even though in the shipyard also, they are fabricate with this the debit arm. This is the vertical support one, and then the H-beam 5 you can use based on the design load that you are required. At this moment, this is we apply the calculation is a 1 ton or 1000 kg. Before to continue with this the calculation, you need to know how much the load on the feet, how much the estimation lifting weight, the weight itself of the Davit, and also the axial load. The vertical impact factor based on the rules 1.5, and then the horizontal impact factor based on the rules also is 0.5. After that, you can see how much the vertical force and horizontal force. You need to know also the bending moment in Davits. If you can see this picture or picture of this the Davit, the height it determined is the L1, L5, the length or the height, and then length of the boom until to here is the L1, and then the mass or particle is the L5, L3, the distance from L3, L2, the distance from this the brace is L5. So you can change the all the text in this blue text, okay, but the others text you don't need to change because this one is based on the rules and based on also the technical mathematics. After you key in all the input, and then you will see this the stress in Davit. This Davit arm property, okay, we are using the 4-inch schedule 80. The material is the 8106B. The yield stress is the 24.31 Newton per millimeter square. And then allowable axial stress normally is the 0.6 from the times yield stress. Allowable bending stress is 0.66 times the yield stress. So all these the requirement based on the American Institute Society construction, or you can referring to the LRFD or any other rules related with the Davit arm lifting. The mass or the vertical support here we are using the pipe. Outside diameter is around 4 inch, 114, and then the wall thickness is the 8.4. Inside diameter is a 9.7, 97. Okay, and we will get this is the automatic output we will get like cross sectional area, section modulus, moment inertia, and radius of gyration. So you don't need to update with this, so don't modify anything, because inside the excel sheet uh, is the complete formula already. So don't change anything unless you know something else that is not the same on the rules, it's not the same in your reference. You might change, but make sure that you understand about this. Another one is the stiffener based bracing. Also, we are using is a 5 is here to support the girder or H beam. And then we have to determine also the property. Okay, from this the property, and you will get this cross sectional area also same thing. Okay, after that we will double check there's a combined section modulus Davit between this stiffener. You need to combine together, and after that you can see this axial stress. This one also is will become automatic. Axial stress at Davit. Okay, and you can see here is a shape. Okay, this one when we reduce the dimension of the pipe, let's say here we make it smaller, maybe 50. Okay, okay, we just okay, let's say we put 50. The still say centimeter, or because this the 50 and in centimeter is a different, so 114. Okay, we increase sorry, we will increase the load. Let's say I want to make it 3000 here, or equivalent with the 29,430 Newton. Okay, and then we will know whether this step. So this one will unset, and this one will become automatically okay unset. So how to make it save this one? You need to reduce the weight, the load acting on this the Davit, because this one is a 3 ton. Okay, if you want to use the 3 ton is here, make sure you need to change the Davit property, like the vertical support or the H beam size. So you just change his here. Okay, if you want to comply with this shape. Okay, so this size is only 1 ton, but when you increase to make it 2 ton or 2000 kilogram, and then you can see the result whether is safe or not. No, you can see here is unsafe. So you might change the either the H beam or the vertical support. Okay, see when I change the to become 300 here, and then automatically will become safe. So return back to 152, and then become unsafe here. So you need to reduce. Okay, so depends on you either you want to increase this size to be 300, and then will become safe. Okay, and then this one will be 2 ton. Okay, so if you want to get the Excel sheet, just go to the www.shipcalculation.com. Don't forget to subscribe to our YouTube channel, Shipcalculation. Okay, thank you very much for watching and see you for the next topic. Thank you very much and bye bye.